Dacite is an igneous, volcanic rock. It has an aphanitic to porphyritic texture and is intermediate in composition between andesite and rhyolite. The word Dacite comes from Dacia, a province of the Roman Empire which lay between the Danube River and Carpathian mountains, where the rock was first described. Composition: Dacite consists mostly of plagioclase feldspar with biotite, hornblende, and pyroxene. It has quartz as rounded, corroded phenocrysts or as an element of the ground mass. The relative proportions of feldspars and quartz in Dacite, and in many other volcanic rocks, are illustrated in the QAPF diagram. The TAS classification, based on silica and alkali contents, puts Dacite in the O3 sector. The plagioclase ranges from oligoclase to andesine and labradorite. Sanidin occurs, although in small proportions, in some dacites, and when abundant gives rise to rocks that form transitions to the rhyolites. The ground mass of these rocks is composed of plagioclase and quartz. Texture: in the hand specimen, many of the hornblende and biotite dacites are gray or pale brown and yellow rocks with white feldspars, and black crystals of biotite and hornblende. Other dacites, especially pyroxene-bearing dacites, are darker colored. In thin section, dacites may have an aphanitic to porphyritic texture. Porphyritic dacites contain blocky, highly zoned plagioclase phenocrysts and/or rounded corroded quartz phenocrysts. Subhedral hornblende and elongated biotite grains are present. Sanidine phenocrysts and oxide are found in some samples. The ground mass of these rocks is often aphanitic microcrystalline, with a web of minute feldspars mixed with interstitial grains of quartzitradimite, but in many dacites it is largely vitreous, while in others it is felsitic or cryptocrystalline. Geological context and formation: Dacite usually forms as an intrusive rock such as a dike-sill. Examples of this type of Dacite outcrop are found in northwestern Montana and northeastern Bulgaria. Nevertheless, because of the moderate silica content, dacitic magma is quite viscous and therefore prone to explosive eruption. A notorious example of this is Mount St. Helens, in which Dacite domes formed from previous eruptions. Pyroclastic flows may also be of dacitic composition, as is the case with the Fish Canyon tuff of La Garita caldera. Dacitic magma is formed by the subduction of young oceanic crust under a thick felsic continental plate. Oceanic crust is hydrothermally altered, causing addition of quartz and sodium. The young, hot oceanic plate is subducted under continental crust. The subducted slab partially melts and interacts with the upper mantle through convection and dehydration reactions. The process of subduction creates metamorphism in the subducting slab. When this slab reaches the mantle and initiates the dehydration reactions, minerals such as talc, serpentine, mica and amphiboles break down, generating a more sodic melt. The magma then continues to migrate upwards, causing differentiation, and becomes even more sodic and silicic as it rises. Once at the cold surface, the sodium-rich magma crystallizes plagioclase, quartz and hornblende. Accessory minerals like pyroxenes provide insight to the history of the magma. The formation of Dacite provides a great deal of information about the connection between oceanic crust and continental crust. It provides a model for the generation of felsic, buoyant perennial rock from a mafic, dense, short-lived one. Dacite's role in the creation of Archean continental crust. The process by which Dacite forms has been used to explain the generation of continental crust during the Archean eon. At the time, the fabrication of dacitic magma was more ubiquitous due to the availability of young hot oceanic crust. Today, the colder oceanic crust that subducts under most plates is not capable of melting before the dehydration reactions, therefore inhibiting the process. Molten Dacite magma at Kilauea. Dacite magma was encountered in a drill hole during geothermal exploration on Kilauea in 2005. At a depth of 2,488 meters, the magma flowed up the wellbore. This produced several kilograms of clear, colorless vitric cuttings at the surface. The Dacite magma is a residual melt of the typical basalt magma of Kilauea.